Good evening and welcome to the Q&A session 16 from the playlist of Basic Mathematics for the NEET preparation. The topic is the differentiation of a function using both the product and the quotient rule. So based on this topic, I have one question for this session which is written here on this board. And this session is in continuation of the session number 15 in which we have done a similar question in which we have utilized both the product and the quotient rule. So here the function is y is equal to x cube into e to the power x divided by ex plus 1. So we have to differentiate this function with respect to x. So we have to find dy by dx. So in this question, I will be first of all using the quotient rule, that is, if y is equal to u upon v, y is a function and which is equal to u upon v, and these u and v are two different functions. So then in this case dy by dx is equal to v du upon dx minus u dv upon dx divided by v square. So this is the quotient rule, and I will also be using the product rule, which is if y is equal to u into v, then dy upon dx is equal to u into dv upon dx plus v into du upon dx. So first of all, I will be using the quotient rule. So dy by dx will be equal to, here x cube into ex can be considered as u, and e to the power x plus 1 can be taken as v. So if I use this quotient rule, then dy by dx will be equal to, here v is equal to ex plus 1, then du by dx. Now here u is equal to x cube into ex. U is equal to x cube into ex. So here now I will be using this product rule. So by using the product rule, I will be getting du upon dx as x cube into the differentiation of ex, so this is equal to ex plus ex into the differentiation of x cube, which is equal to 3x square. So here du upon dx will be equal to x cube into ex plus 3x square into ex. So here I will be substituting this value here, that is du upon dx will be equal to x cube into ex plus 3x square ex. Minus u. Here u is equal to x cube into ex, x cube into ex into dv upon dx. Now dv upon dx means v is equal to ex plus 1, so dv upon dx will be equal to ex divided by v square. So here v is equal to e to the power x plus 1 whole square. Now we have to simply simplify this. So from here we can see that this ex plus 1 and this is equal to x cube into ex plus 3x square ex, 3x square into ex minus x cube into e to the power 2x divided by e to the power x plus 1 whole square. So from here I will be getting e to the power x into e to the power 2x into x cube by multiplying this ex with this plus 3x square e to the power 2x plus x cube ex plus 3x square ex minus x cube e to the power 2x divided by ex plus 1 whole square. So from here, this x cube e to the power 2x, this will get cancelled out. So finally, dy by dx will be equal to, from here, this 3x square, or you can say this x square ex can be taken as common. X square e to the power x can be taken as common. So in bracket I will be getting 3 ex, and here ex to the ex into x square has been taken common, so this I will be getting plus x, and here x is plus 3 divided by e to the power x plus 1 whole square. So this is the, so the dy by dx of this function is equal to ex into x square in bracket 3 into ex e to the power x plus 3 divided by ex plus 1 a whole square. So in this question we have used the product and the quotient rule simultaneously, and in order to find the first differentiation of this function y. So thank you very much for joining this session. In the next session I will be coming up with a different type of a question from the same topic of this differentiation of any function using the product and quotient rule. So till then, have a nice day. Bye.